My name is EDREENA and I will start our presentation with introduction. As you know, our project is about stormwater drainage design. So, stormwater is surface runoff, is water that originates by rainfall on the surface of the earth, discharged over roads, parking lots and rooftop until it reaches a body of a water storm rain. Therefore, stormwater drainage is an interconnect network of structured channels and underground pipes that distribute water, which is rainwater, to ponds, lakes, streams and rivers. Next, changes of the drainage pattern and increases overland flow, resulting in flooding and other environmental issues that might impact road infrastructures and other urban utilities, especially stormwater drainage. Next is problem statement of our project. There are two problem statements, which is first, the flow channel size is insufficient for the area and should have carefully evaluated while developing the drainage system for stormwater. Second, flooding and easily overflowing across the road when heavy rain due to insufficiently planned and design of the location's drainage system. Moving to next point is the objectives of our project. First, to figure out the factors that causing floods at Taman University Parit Raja Johor. Second, to propose new design with suitable size of drainage system according to the authorities in Malaysia. Last objectives, to suggest flood prevention strategies in consideration of the studies and findings. Next point is study area. Our group study area is located as instructed in hydraulic projects instructions, which is along drainage at Taman University Parit Raja Batu Pahat, Johor. This drainage approximately 490 meters long, depth of 2.0 meters and 5.2 meters wide, and the average slope along the drain is 0.7 meters.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURUL and NAJIIHAH binti AZMAN. So I will present about our methodology. So this is our flowchart for this project. First step, we choose our study area, and then we go for site survey and we take note some of measurement about the area. Next is we identify and justify the reasons why flash flood occurs at a location. Proceed with one flood mitigation method proposed, and then next analysis and calculation of proposed method made, and then the last one is full project report completed. This is the figure of our study area. Our study area is a part of Taman University Parit Raja area. So since it is the most typical method for calculating runoff flow, we are utilizing the rational method in this study to identify the peak runoff. So next is calculation steps. Firstly, we calculate runoff coefficient of mixed development C. The equation is shown in the slide. C average is average runoff coefficient. C dot J is a runoff coefficient of segment. A dot J is the area of segment, and M is the total number of segments. Secondly, calculate friction slope S, which is L is the length of the channel, and then we calculate the area of trapezoidal channel of our study area. The B is the width of the channel and the Y is depth of the channel. Next is we calculate wetted perimeter with the equation for trapezoidal channel. Next, we calculate hydraulics radius R, which is A is the area and the P is the wetted perimeter. Next is calculate drain flow, which is TD. N is Manning's-Roth coefficient. TD is a travel time in the drain. And next, we find rainfall and intensity, which is I is an average rainfall intensity, T is for average recurrence interval, and D is for storm duration. Next, we proceed with the calculation of Q rational. Q is a peak flow, the C is runoff coefficient, I is average rainfall intensity, and A is a drainage area. Then we calculate the Q capacity, which is A is an area of the drain, R is area per perimeter, and S is a slope, and then N is a roughness, and the last one is we compare between the Q rational and then the Q capacity.
Assalamualaikum and hi, my name is HIDAYAH Binti BAKAR. We present about the condition of study area with reason flash flood occur at location chosen. I will start by explaining to you all about the channel condition. From the figure in this slide, we can see the surface of the channel was covered by vegetation growth which is overground grass. Next, we also can observe there is an accumulation of silt which is we can say the silt is came from wind and rain medium that will affect the channel condition which is can form the water ponding, and as usual the channel has contained the debris that will accumulate in the channel and cause clogging. Normally, the debris in the channel is due to the human activities. Not just that, there is a minor erosion occurred at this channel. Now, I will continue the presentation by sharing to you all about the ground level condition. Based on the channel observation conducted, we notify the type of soil can be classified as sandy clay type, which is less permeable than sandy soil. This means the ability to allow water flow is low. Next, the ground level of these channels is uneven, which is water will accumulate and flow at slower rate in certain area. The ground level of channel also contain debris and has vegetation growth. The debris will obstruct the flow in the channel, meanwhile the vegetation growth will absorb the water. All of the conditions were explained will affect the water flow and consequently can lead to the flood and channel damage. Based on the channel and ground level condition that I was explained previously, there is several factors as listed in this slide. I will justify why the point present in the slide as the reason of flash flood occur. Firstly, the lack of inspection and maintenance operation. From what I was explained in the previous slide, the channel was filled with vegetation growth, debris and silt accumulation. The vegetation growth will trap the sediment while the debris will lead to the channel clog. All of the conditions that I mentioned will fill out the channel area, which reduce the amount of water can flow through it. In other words, the channel capacity was reduced that will contribute to the flash flood occurs, especially when the channel need to accommodate the water during extreme weather such as heavy rain. We can see the channel capacity is most important things that should be considered to ensure the size of channel with maintenance operation regularly were enough to accommodate the water flow, especially when the channel located is at the road and parking area. This is because due to the urbanization planning that effect on the channel capacity, such as the channel that located near to the area that has impervious surface will lead to the water runoff increased due to the surface do not have ability to absorb water into the ground. As summarized, all of the factors become an obstruction that will increase the restriction to water flow and thus lead to the flash flood. Next, the main causes of flash flood occur is come from the ground level channel condition. Basically, the ground level for this channel is uneven. This will lead to the situation which is water pools and flows more slowly. Not just that, the ground level also containing debris that will lead to the channel clog or obstructing the water movement. Additionally, the causes of flash flood also can be from erosion and the ground around the channel improperly graded. As simply, what I explained just now will increase the risk of flash flood to occur as well as lead to the channel damage. That's all from me. Thank you.
Okay, my name is Zarina Binti ZAHRIN. My number matrix CF20144. I will present about result data and analysis. In result data analysis, we have drainage area which is based on the proposed catchment area in this project. By using Google Earth Pro, the total area of watershed is around 5.18 hectare. The maximum area of water catchment due to rational method is fixed at 80 hectare. Okay, for the first picture, show the area of water catchment in Google Earth Pro, and for the second picture is elevation and length of drainage in Google Earth Pro. Equation of rainflow for hours, we got D is 0.0687 And the next equation 2.3.8, we got the rainfall intensity is 4 to 1.642 millimeter per hour. And for the next equation 2.3.9, we got the Q rational is 5.8 meter square per second. And for the equation 2.3.10, we got the Q capacity, which is 90.22 meter square per second. And for the table 2.3.10.1, we got the main equation is n is 0.035, and the last equation, we got the last equation when we compare Q rational and Q capacity, we got the answer is 12.51 meter square per second. For the next one, we want to determine the discharge of Q-peak. For the first picture is trapezoidal section of drainage. This is a picture for layout trapezoidal section of drainage. And the table 4.2.1 is calculation discharge of case study drainage, which is for reference 1, table 2.3.2.1, we get the output C is 0.95. For the equation 2.3.2, we got the C average 0.63, and equation 2.3.3, we got the friction slope 0.0041 meter. For the equation 2.3.4, we got the area, which is 9.7 meter square, and for Z is 0.175. For the equation 2.3.5, which is the perimeter, we got the 8.6 meter, and equation 2.3.6, for the hydraulic radius, we got 1.128 meter. And for the next equation 2.3.7, we got the drain flow, DD is 4.12 minutes. For the next design, we propose new drainage design, and the picture is show layout trapezoidal proposed design section of drainage, which is based on the calculate and the analyze data. The cause of flash flood in the area is because it is a small area of the drainage and too shallow, and it is also a result of dumping garbage in the drain area. Therefore, to prevent the flash flood from occurring continuously, the channel perhaps can be enlarged and deepened, so it can raise the flow of water more than calculate flow discharge of case study drainage, which is 50.01 meter per second. Next, for the table 4.341, it shows the calculation discharge of proposed design drainage, which is for reference table 2.3.2.1. we got the output is C equals 0.95, and for equation 2.3.2, we got the C average is 0.80. For the equation 2.3.3, we got the slope is 0.0041 meter, and for the equation 2.3.4, for the flow area, we got 60.047 meter square, and for Z is 0.283. For the equation 2.3.5, we get the wet perimeter is 0.735 meter. For the next equation 2.3.6, we got the radius 1.4 meter. And for the equation 2.3.7, we got the drain flow TD is 3.41 minute and for T is 0.056 hours. And for equation 2.3.8, we got the rainfall intensity is 437.645 millimeter per hour. And for the equation 2.3.9, we got the Q rational is 6.0 meter square per second. For the equation 2.3.10, we got the Q capacity is 38.38 meter per second. For the table 2.3.10.1, we got the Manning roughness coefficient and is 0.035. For the last equation 2.3.11, we compare Q original and Q capacity and we get the total Q is 22.90 meter per second. Since Q rational is 22.90 meter per second, bigger than Q average is 12.51 meter per second, meaning that the proposed new design of channel section is passed.
Hi and hello. Okay, now I'm going to explain about my part, which is discussion part. So if you look at here, we have JKR design and proposed new design, which they are length, depth, hydraulic, mean radius, flow rate of drainage, and the remarks are passed. So I can give justification on this method I chosen. Water that causes floods should be kept away from road structures whenever possible, or efforts should be made to remove it swiftly off the road surface by installing a well-designed drainage system. Okay, so the proposed new design was justified since the Q design is greater than the discharge Q peak. So since the flow rate is higher, then the design is approved. Okay, so this is because the drainage system's cross section is very based on their length, depth, channel, causing the flow rate to rise. So in this project, the cross sectional of the drainage area is measured using a logical way to determine the value of discharge. For this method, we discover the cross sectional is 12.8 acres. That means 5.8, 5.2 hectares. The types of grass drains with short grass cover less than 150 millimeter determined with the value of n as the given value is 0.035. So it is based on the value of Manning's roughness coefficient. And so one of the most significant parameters in the hydrological calculation that represents the loss of energy in open channels, and it also is frequently used to calculate the discharge and flood water elevation. So the hydraulic radius here, so the hydraulic mean radius can be calculated after determining the Manning's roughness coefficient, and so the result is 1.495 as we propose here new design. Okay, so the drainage friction slope was calculated and we got 0.0041 meter. So as a result, Manning's equation holds true for a constant water flow rate through a channel with a constant size, shape, roughness of the slope. So, okay, so due to the severe rain, culverts and bridges along the road overflow and water covers the road surface during flash floods. As the design clearly shows, varying widths of channel, we chose to elongate the length and depth of the channel to avoid it occurring in time. So that is our discussion part. Okay, hi everyone. Now I'm going to uh, present about the additional requirements of a good drainage system. Okay, so a good drainage system is crucial for efficient water management and flood prevention. So these are the five requirements needed to have a well-designed drainage system. Okay, so the first one we will look at adequate capacity. So the drainage system should be handle the expected volume of water during normal and peak flow conditions. It should be designed based on accurate hydrological data and considers factors such as rainfall intensity, catchment area, and surface runoff characteristics. Okay, these are for the first one. Then the second one is effective network layout. Okay, so the drainage network should be designed to efficiently collect and transport water away from the area. So it should be include a well-connected network of pipes, channels, and inlets that can effectively capture runoff and direct it towards appropriate discharge points or storage facilities. Okay, so the third one is a proper grading and slope. So the drainage system should be designed with proper grading and slope to facilitate uh, the flow of water. The pipe channel and surface should be appropriately aligned to ensure gravity driven drainage without any stagnant areas where water can accumulate. Okay, the fourth one is maintenance and accessibility. So the drainage system should be designed with ease of maintenance in mind. Access points such as manholes and cleanouts should be strategically placed to allow for regular inspection, cleaning, and repairs. So proper access and clearance should be ensured that to prevent the blockage and facilitate routine maintenance activities. So every time need to take maintenance regularly. Okay, for the inlet design, the last one, inlets such as grates and catch basins should be strategically located to capture surface runoff effectively. So the design should consider factors such as inlet spacing, size, and shape to minimize the risk of clogging. So and maximize water intake capacity. Okay, so these are the five requirements that needed to take or additionally can be taken to have a good drainage system. So overall, we can say that a good drainage system should effectively manage surface runoff, prevent localized flooding, and protect the surrounding environment. It should be designed with holistic approach, considering factors such as capacity, maintenance, integration with natural systems, and sustainability for long-term effectiveness. So this is very much important requirements that need to be taken. So that's all.
Next, I will present about our conclusion. Designing pipes, plumbing systems, sewage systems, drainage, rainwater collection systems, wastewater treatment systems are included in hydraulic engineering. Civil engineer is responsible for designing systems that move water or sewage from one place to another as safely and efficiently as possible. In the case of this project, when it rains excessively or during the rainy seasons, floods frequently occur in the study area. Due to the overload of these systems, water does not drain as quickly as it should during severe downpours. In other words, drainage systems clog and sometimes water surges to the residents. Due to the tiny area, it can be seen from the study that current design is insufficient to sustain the excessive load capacity when the high intensity of rain occurs. We studied some formulas to calculate the drainage peaks discharge as well as to suggest the peak flows design for the on-site drainage. By creating a new drainage system with a greater discharge, it will be possible to stop flash floods from happening when it rains in a portion of Taman University Parit Raja. To conclude, one of the most important parts in the residential community is the drainage system. Drainage flows need to be properly controlled to maintain the safety and cleanliness of the natural area. It is necessary to establish a trustworthy drainage system in order to prevent this situation and reduce damage. That's all from me. Thank you.